Hello everyone, I am Vinayak Banerjee from College of Engineering and Management, Kolhagat. Today, on behalf of me and my fellow authors, I am going to present the paper on multi-document text summarization. The sole goal of automated summarization is to extract a summary from the documents which would contain the most informative ideas contained within the document. We have developed an algorithm to enable this automation and tested it on 5 or more sets of data on topics from varied journals, and the output obtained was verified by a linguistic expert. With the exponential growth of online data, retrieval of data in a subtle way is of utmost concern. The solution as a result is dependent on computationally extracting informative data from a set of documents to produce a concise formatted data stream. There are two types of summarization, as the name suggests: single document text summarization and multi-document text summarization. The first is obsolete, as the latter speaks for both cases most of the times. The two types of summarization that we will be talking about are extrinsic, that is extractive text summarization, which focuses on word-to-word matching, and intrinsic or abstractive text summarization, which focuses on meaning-based matching. Now let's move on to the field of application and where this technique could be applied. Web page. Information retrieval using web crawlers has led to various forms of documents in various data formats. These can be summarized using web page automated text summarization. Email. The conversation threads may be summarized to get an idea about the relevant topic of discussion. Speech. Narration may be converted to text and synopsis may be needed for events such as seminars and lectures. This technique comes in handy for such cases. Medical, where huge research papers may be summarized for the key contents for an overnight study by the doctors. Let us now move on to the key terms that I will be talking about throughout the presentation. Normalization, in the most basic form, is removal of unnecessary text, or transformation to canonical form, like the shown example where apostrophe and decimal have been removed. Next is lemmatization. It is the process of pre-processing to increase the lexical coverage, providing better results in the process. I will be going into the details shortly. Next is categorization. Bundling of documents of the same context into a single document so that the program can run easily on such a document. Clustering, grouping of similar sentences together in layman's terms. This too will be explained in detail shortly. TF-IDF. This plays the most decisive factor in judging and extracting of the sentences with the highest concentration of information. In layman's terms, it decides what to keep and what to discard within the documents. It is the constituent of a formula to calculate the word weights. WordNet. The English WordNet is a machine-readable dictionary where words are present with some semantic relations among them. This idea is used to find synonymous words and match words more efficiently while following the algorithm of intrinsic text summarization. Now I will be moving over to the proposed approach. The idea that we have developed is purely based on our observations on how we humans summarize a document. We read the text, get an idea about the concept, and read it to find the important points thereafter. We select the important sentences and tweak them to merge or shorten them to capture the ideas and also clamp similar ideas to form a shortened version of the document. This is simply posing the problem as a sequence labeling problem of labeling similar sentences and grouping them together. Now, I will be thoroughly explaining the flowchart along with the algorithmic details. First is categorization of normalized text. Non-normalized text, meaning the text in its original form before any process is applied on it from multiple documents, is categorized or appended into one so that the working of the algorithm on files becomes easier. Also, at the end of the algorithm, the order of sentences no longer remain the same. This step preserves the chronological order of the sentences, which would be required as a reference while creating the final summary. Here is a diagrammatic representation of what a non-normalized text looks like. It's a regular text. Manual normalization of text set. Non-normalized text is then manually normalized. This step involves removal of special characters, spaces, conjunctions such as hyphens or underscores, subscripts, superscripts, double spaces, anything that does not give any special meaning to the document. Even numeric values are removed for that purpose, but importance of the sentences will be calculated considering the relevance on the whole document set and not on specific facts. This is what a normalized text dataset looks like. The categorized document is then lemmatized in the form word, also speech, and the root or stem word. This increases the lexical coverage of the algorithm, meaning the words go and went would appear as different to the computer. You would not be able to find the matching of words while using any coding methodology or algorithm. To get rid of this problem, CST's online lemmatizer is used, which is a tool available on the web. This tool is used to process the whole document and get the lemmatized form of the document. Here is an example of what a lemmatized text data would look like, the format being word, parts of speech, and the root word. Then we move on to the recognizing of stop words, or in simple words, removal of insignificant words. Prepositions, auxiliary verbs, conjunctions, articles, etc. don't provide any extra meaning to the sentences. They are simply present in the sentences for proper structuring, which has no value here. We have taken up the parts of speech to be removed from Google's optimization searching techniques database of stop words, and have also added in a few parts of speech from other sources deemed necessary to be removed. We find such stop words and write them in a file. This is an example of what a stopword file looks like. It has been separated using the hash symbol. Next is stopword removal. They are programmatically removed by simple word matching, and a document with only keywords, that is, words conveying the meaning to the document, is generated. This is the documents with keyword generation step. This is the file containing only keywords where lines have been numbered and separated using special symbols for programming purpose. This file does not contain any stopwords, that is, irrelevant information. This is the most important step of the algorithm. Here words from two sentences are matched lexically, and if two sentences which are found to have 3, 4, and 5 or more words common, then they are clustered into a set, with simply meaning group of similar sentences together. This allows the elimination of redundant sentences easily. I'll explain this with a diagram for better understanding. Here is an example of the clustered document. As we can see, the sentences have been ordered in this format of 5, 4, and 3. A sentence which has 5 words similar to another sentence is clustered together and kept within the 5 brace. Then the same sentence is compared with other lines to find if 4 of the words are similar. Then they are placed within the 4 brace, and then the 3. Such clusters are separated by a caret symbol and generated one by one, where each cluster of 5, 4, and 3 is considered to be grouped in such a way that the similar sentences are kept together. TF-IDF is used to calculate the sentence weight by simple summation of word weights calculated programmatically from the normalized text file generated in second step. Explaining the terms again, TF is the number of times that the term T occurs in document D. IDF, it is the inverse document frequency. We obtain this measurement by dividing the total number of documents by the number of documents containing the term. Suppose the word Ravindranath. TF into IDF is 23 because the word Ravindranath is present 23 times in the document, and IDF is 1 because Ravindranath was present in all the 3 documents where the code was run. Similarly, birth was present only once, so it's 0.333 as 1 by 3 comes to out to be 0.333, and the birth was present once in the document, so the word weight becomes 0.333. Weight is calculated by the formula as seen TF into IDF, and the summation of individual word weights later is done to obtain the sentence weight, thus allowing recognition of the most informative sentences within the document. The form in which data was plotted can be seen in this diagram. This is an example of the defined cluster format that is generated by comparing the word weight file with that of the normalized text. Sentences sorted in decreasing order of sentence weight. The sentences within the cluster are internally sorted in decreasing weight. And a certain percent of sentences are selected from each subset of 3, 4, and 5 or more similar words, and thus a defined cluster of unique sentences is obtained and kept grouped in a defined cluster file. The format of the new cluster is shown in the diagram. This is the new defined cluster where line number and words are kept together within a cluster, and the 5-4-3 bifurcation is removed. It is ensured that these sentences are completely unique and free from any redundancy. User is then asked for the summation percentage, and according to the input, same percent of sentences are extracted from the cluster and kept in a summarized document file by comparing it with the original file to preserve the ordering of the sentences. Thus, the summarized document is obtained. This is the extrinsically summarized text document. This has been compared with the initial file that was kept and has been plotted. Now, for the intrinsic text summarization. Step 1 to 6 are exactly same as they were in extrinsic summarization technique. The documents with keywords generated file is at our hand. The sentences are then splitted into words and semantically matched. The process being depicted in the figure where we see two sentences. Semantic matching is obtained by finding out the synonymous words from WordNet 2.1, a knowledge-based database. These synonymous words are duly matched to form more accurate clusters, ensuring the removal of redundant sentences in a more effective manner. We see in this image how a sentence is split into words and its synonyms are compared to map the matching, thus giving an accurate semantic relation. Step 9 to 12 are exactly same as they were in extrinsic summarization technique, where defining cluster and extraction of highest weighted sentences is done to obtain the summary. Thus, also the result in semantic summarization is obtained. We have then plotted the tables and have found out that intrinsic text summarization gives much more concise result, and the linguistic expert verified that the quality of the document obtained also is much better in intrinsic text summarization. Also, varied genres of documents seem to be working differently in both techniques, but an overall inspection of the documents leads to the fact that intrinsic summarization provides a much more accurate result than extrinsic text summarization. Few close observations. The document containing equations and numbers and special symbols are not very algorithm friendly. They pose problems and threats to the algorithm. Again, negative sense of two sentences, that is, two sentences with just a difference in the word no or a negated meaning, may be mapped as same and may be eliminated, thus defaming the work of the algorithm. This methodology includes inclusion of two different sets of ideas of summarization, and both seem to be working fine with different sets of data within the constants that are provided. But the intrinsic text summarization is said to have give a better result, which has been verified both by the line numbers and by a linguistic expert. For future work, deeper mining of data may be done with the help of a larger database considering synthesis up to higher levels. Also, we may extend this to other Asian languages, study the results and improve the algorithm and see what can be done so that this would become other language friendly. That's all from my side today. Thank you everyone.